Okay, so solving this equation, we need to start by figuring out what the least common denominator is. What is it for these? X plus 2 times x plus 7. How do we know? This factors as x plus 2 times x plus 7. It doesn't, nothing about it like has to be that way, right? That it is what it is. But for, practical purposes in terms of what's going to happen later and getting a thing we can actually solve, a lot of times you're probably going to have a pretty good indication from these of how that thing would factor if it's not already. So the lowest common denominator, again, we have to like sort of build up to, right? It's the smallest. I'm going to borrow Dr. Martinez's note here from yesterday. It's the smallest number that everything divides into, or it's the smallest thing that I can build up to by multiplying. So if what I have already is an x plus 2 and an x plus 7, and then their product, right? So I've got thing 1, thing 2, and then the product of those, the least common denominator, the smallest thing they all go into would be that product, right? Because that sort of covers or incorporates all of it. Okay. And if that's the LCD, then whatever else happens as we go through solving this, I know that in the original statement, in the original thing, x cannot be -7 and it cannot be -2 because that would make all or part of the original thing undefined, right? That would give you 0 in the denominator somewhere. If we want to think about it as functions, these things have vertical asymptotes at -7 and at -2. When we solve for something, we're saying that at this x value, they meet, right? They intersect. That can't happen if it's not even defined there. Okay, so we've got that. We've got the LCD. We've got the discontinuities. Now what? Okay. This one we need to multiply by x plus 7 on top and bottom in order to, again, sort of build up to that common denominator, right? And in the next term, we're missing the x plus 2 part. The thing on the right is already over the LCD. We don't need to change anything there, right? So x plus 7 over x plus 2 times x plus 7. And 3 times x plus 2, again, over the LCD, equals 5 over our LCD. So we've now rewritten all 3 of these individual fraction terms so that they've got matching denominators. So they're all the same kind of thing, right? Why do we care about doing that? Now they're all the same kind of thing, right? They all have the same denominator. So now we're talking about, comparing like things. So it's, I think yesterday I compared it to like an apples and apples kind of thing. Originally, it was all different kinds of stuff. Now they're all the same kind of stuff. So now we get to do the fun part, which is that in order for this to be true, it has to be that the stuff across the top is equal, right? That statement across the top works. So we can, either think about it as taking the whole thing and multiply it through by the LCD and cancel all the fractions, or just, in order for that statement to make sense, it's got to be the case that the stuff across the top line basically is true. Which makes life considerably easier, right? So I'm taking, the stuff here and multiplying the whole thing through by that LCD, which just knocks out all the fractions. Just gonna write it like that. And now we just need to solve this. So x plus 7 plus 3x plus 6 equals 5. That's a linear equation. All I need to do is combine like terms. I'm going to subtract 13 from both sides and then divide by 4. There you go. And we get x equals -2. This 5? Oh, okay. Yeah, that's the 5 that's always been there. And then here, just combining like terms and then subtracting the 13 over. So the whole thing, because -2 is a problem, right? If I let x be -2, then right off the bat, the very first term, I get 1 divided by 0. When we talk about checking solutions here, it's not that I need to like go back and plug in and oops, one side was 7 and the other side was 12. It's not like that. Like the arithmetic's just not going to line up, you know, assuming that I didn't like make a mistake somewhere or whatever. But what we're checking for is that somehow I haven't gotten information in the middle in the process of doing all this that doesn't make any sense in the original problem. So all I'm really looking for is if a thing that shows up like it's a solution here, right, a thing that poses a solution here, would give me 0 in the denominator somewhere, right? Because that means it's happening at a place where something's undefined, at a place where like a vertical asymptote happens. That does happen here. Because if x is -2, this term will be undefined. It's not in the domain of the original thing. So we have to throw it out. And that means that this has no solution. For the most part with these, once we clear all the fraction stuff out and end up with a thing to solve here, it's got to be a thing we know how to solve, right? This one was linear, degree 1. You'll see plenty that end up being quadratic too. That's probably about it for the most part. You know, we can solve some degree 3 and 4 things, you know, sometimes. So you might see 1 or 2 of those show up, but probably this is going to be either a linear or a quadratic thing you got to solve, which means we're going to get, you know, 1 or 2 solutions here probably. But checking them against the original stuff, anything can happen, right? Here we got one thing, we had to throw it out. That means there's none. We could have 2 and one of them's good and the other one's no good. We could have 2 and neither one of them work. We could have 2 and they're both fine, right? So like, I don't necessarily know going into it what to expect in terms of how many answers I'm going to get, that kind of thing. There's a little more variability in what can happen. This one though, no solution. Okay, questions about any of what we just did, or we feel okay about that, I think. Okay, cool. So there's 3 more here. Let's just take, 10, 15 minutes or something for y'all to work a little bit on those. I would encourage you to, I can pause the recording. Okay, what is the least common denominator for this one and number 2? Smallest thing that x squared and x and 1, if you want to think about it that way, smallest thing they all go into. We have to build up, right? So the fact that this is x times x, think about it as like if the if you were talking about fourths and halves, right? If I'm adding like 3/4 and 1/2, I can't break this down further. I have to build this one up, right? It's the same idea. So the lowest common denominator, least common multiple, smallest thing they all go into would be x squared. Because I can take this up to x squared if I multiply by x on top and bottom. I can't take the 7 over x squared. I can't like take an x out of that. Does that make sense? Maybe. Okay. We can work with maybe. To use that least common denominator, first term is good to go, right? 7 over x squared. I've already got it there. We're good to go. Second one, over x, I need to multiply a factor of x into the top and the bottom, right, to get it over x squared. And then the right-hand side, I need to multiply in x squared over x squared. So we've got 7 over x squared minus 8x over x squared is negative x squared over x squared. And now once they're all the same kind of thing, we can basically drop the fraction part, right? Or multiply the whole thing by x squared if you want to think about it that way, and stuff cancels. Right, that's kind of more dramatic, so that's fun. All the x squared terms cancel, and we're left with 7 minus 8x equals negative x squared. Which is quadratic. So what should we do to solve it? But first, everything to one side. We got to set it equal to 0. So I'm going to add x squared to both sides because I don't like having to deal with leading coefficient being negative. So I'm just going to add this over to get x squared minus 8x plus 7 equals 0. Right, yeah, that one factors nicely, or you can use the quadratic formula. As usual, like you do whatever you're more comfortable with. And what do you get? X minus 1, x minus 7 equals 0. So as solutions then we get 1 and 7. Okay. And do 1 and 7 both work in the original equation? What's the only thing that would not work in the original equation? The only place it's undefined. X equals 0. Because if x is 0, that makes that 0. It also makes that 0. So in this original, statement where I find the LCD, I know that x can't be 0. I got 1 and 7. It means if I, plug those in again, I don't need to like check all the arithmetic, right? I'm not saying plug in and actually do all the arithmetic stuff, but if x is 1, this is 7 over 1, which is fine, right? I'm not going to worry about what it is. It's defined. It's a number. 8 over 1, again, fine. 7. Denominator here would be 49. Okay, that's not 0. That's all I care about. 7, good, right? These are both fine then. So 1 and 7 are the two solutions. Just so you know what I'm gonna look for in grading stuff on like a test question or whatever. Somehow I need to see that you've thought about whether solutions work or not, right? Even if like here they're both good, I don't need to like, throw one out and say that, oh, actually 1 is the only actual answer. Whether they're good or not, though, I need you to, part of the grading rubric is going to be, that you've thought about it somehow. So writing something like this would work, writing something like this would work, plugging them in would work, something, even just, some little scribbly scratch work or whatever, and like, a check mark, a smiley face by them or something. Just, show me somehow that you've thought about it and didn't just, sort of get lucky that they weren't, extraneous. Okay. What's the LCD here? X times 2 minus X. And what does that mean about the domain and where it's undefined and all that stuff? Can't be 2. Also can't be 0. All right, those in the other order. Can't be 0 or 2. Okay, and then when we rewrite these 3 terms, the first one's missing a factor of X. And the second one's missing 2 minus X. And the thing on the right-hand side, 5, it needs all of it. So we end up with X squared and 2 times 2 minus X and 5 times X times 2 minus X all over that common denominator. And that means we've got X squared plus, what is that, 4 minus 2X is 5 times X times 2, 10. Minus 5X squared. I'm doing a couple things at once, right? I distributed here and also cleared out the fractions. Oh, Ellie, maybe that's what happened. There was a sign thing somewhere in there.
I did X minus 2 instead of 2 minus
Oh,
X.
okay, okay.
Only on that side.
Gotcha. And I trusted you.
That's on you, man.
I know.
That's on you.
That's today I learned. Okay. Now what? It's quadratic. So get everything to one side. Yep. So I'm going to subtract 10x. I'm going to add 5x squared to clear out the right-hand side. So 6x squared minus 12x plus 4 equals 0. 6 and 12 and 4. You could take 2 out if you wanted to, but kind of no matter what, we're going to have a leading coefficient here that's not 1. So I would probably just go straight to the quadratic formula if it's me. It might factor. I don't know. Doesn't matter. It might factor. It might not. I don't know. I would probably just go straight to the quadratic formula though. Once I see, you know, the shape of this thing, and solve from there. And then again, once I get to solutions, I need to make sure that 0 or neither 0 nor 2 show up there, right? Or if they do, I have to get rid of them. Okay. 4 looks weird, right? 4 looks different than the rest of them, but what's going on there? Yeah, those negative exponents, those are reciprocals, right? Negative exponent means flip the thing upside down. So how would we rewrite this to make it look, you know, more in line with all the other stuff we've been talking about? So the negative part flips it over, like x to the minus 1 is 1 over x. Right. Oh, sorry, that. A different negative 4.
Yeah.
Gotcha. Right. No, that's just a number. Yeah. Right. Yeah. That's just the number 4 or negative 4. X to the negative 4th, the negative part flips it over. The 4 just acts like a normal exponent. So if I'm going to rewrite this whole thing, x to the minus 4 is 1 over x to the 4th. And x to the minus 2 is 1 over x squared. Only there's 3 of them. And then, yeah, that constant term is just constant. So it's not that you flip the whole thing upside down, it's that you flip the individual pieces because that's where the exponents are, right? This power, this -4 power is only on that x term. So that's the only thing that flips. This -2 power is only on the x term there. So that's the only part of it that flips. The 3 doesn't go with it, right? The 3 is 3 times then the thing with the power. Right, so I'm saying, here, this would be the whole thing flipped. Right, that's the difference. But since the exponent there is only on the x term and not the 3 part of it, it stays where it is. Okay, well, now it looks more like the stuff we've been talking about. There are actually a couple of ways you can approach this. We can do the same thing that we've been doing, right? What would the least common denominator be for x to the 4th and x squared? X to the 4th. Right, because really this is 1 over x to the 4th, and this one's 1 over x squared. So the LCD would be the 4th power. You can do that, and that makes the fractions and stuff go away. And that'll feel very samey to the other stuff we've been doing. So I'll, leave that there. Another way you can do this, and this is one of those things where like the first step is, notice that this happens. I know like we don't always do that, right? That requires you to, kind of see a thing that we don't always see. But for the sake of talking about it together, another way that you can approach this is to notice that these powers, right? 4 and 2, and then a constant term, those are walking down by half, right? Like 4, 2, 0. That's got the same kind of shape or form as a quadratic, right? So a way that I could rewrite this is that I could think about splitting that 4th power up. I'm not saying you have to do things this way. I'm just saying this is a way to do it. Then this thing looks like a quadratic, right? If I ignore for a second that 1 over x squared term inside those parentheses makes me nervous, it looks like a quadratic only in terms of this orange squiggly thing, right? Well, we know how to deal with quadratics, right? It's squared, linear, constant term. Can we factor a quadratic where I need things that multiply to -4 and add to -3? Yeah, right? Factors of 4. Okay, well, 4 and 1 or 2 and 2. Opposite in sign. So yeah, we can factor that as -4 and +1. Only it's in terms of this. But that's okay. I can, having it factored means I can split it up and set them equal to 0 and solve. And what that would tell me is that this thing, whatever it is, could be 4. Or this thing could be -1, right? And all I've done for, the last few bits here is lean on the structure of the algebra that's here, right? Factoring the thing. It hasn't mattered at all what's under here. Well, but then at some point I got to actually look. So I didn't solve for x, I solved for the reciprocal of x squared. Well, okay, that means I have some work to do still. I can flip those though, right? The point of doing that is to break it down to simpler, smaller pieces that are easier to manage. If 1 over x squared is 4, then x squared is 1 over 4. And that means that x is plus or minus a half. I take the square root. And similarly here, the reciprocal of -1 is -1. And then taking the square root, I would get that x is plus or minus the square root of -1, which is I. So to get from here to here, you need to take a reciprocal, right? Flip it over. So I did the same thing to the other side, right? Think of this as 4/1. I'm flipping the left-hand side, so I also flip the right-hand side. Yeah. The same thing's happening here. It's just that -1/1 is still -1/1, right? So the reciprocal is the same thing. Yeah. This is the same thing you would get if we, approached it using kind of the same idea that we've been doing and like multiplied all through by x to the 4th and then broke it down and everything else. You would end up at the same place. So you don't like have to do this, but it's something that you might, be on the lookout for, because usually if something, if the thing that I'm going for in writing the question is getting you to kind of think about this quadratic form thing, I'm usually writing the problem so that the factoring stuff would be pretty straightforward, so that like if you get it, right, if you see that that's going to work, then this ends up being not all that difficult. Whereas if I go about it the other way, some of the algebra might get a little bit messy. I took the square root. So the square root of 1/4 is the square root of 1 over the square root of 4, which is 1/2. So half. Yeah. And then you pick up the plus or minus because we're doing the square root. Yeah. Okay. We'll leave that there. I haven't finished writing up solutions and posting those yet, but those will be up soon so that you can, I know we went through those kind of fast, but you can work back through and check details and stuff. For Thursday, I want you to think about this. We're going to talk about inequalities. I want you to think about how you would do that on 5 using what you already know about solving and what you already know about rational functions and what you know about inequalities already. There's not really going to be anything new here. We're just going to do the same, usual stuff